Hey, hello, and welcome to the show. It's me, JP, and here we are in my workshop. Thanks for stopping by today for another episode of John Park's Workshop. What do we got going on here today? Well, I'm back. I was out last week, but I am here now, refreshed and ready and excited because we got some cool stuff to do, some neat things to build, some cool stuff to check out. I've got a coupon code for you so you can save some money in the store. I've got a recap of my product pick of the week. I have a loud air conditioner. I know people claim they can't hear it, but I'm shouting over it. There we go. I have got a CircuitPython Parsec for you. There is a Learn Guide recap I want to do. There are project kickoffs and updates and more. And explainers, and even a cool tool that I want to show off. So lots of neat stuff. Thanks everyone for stopping into the chats. We've got Dave Odessa and Beata Graf Abdelhagen over in the YouTube chat. Hello, thanks for stopping by. And then our other main chat is right here. If you are looking for the chat, if you're on Facebook or something like that and it doesn't appear to be very active and you're wondering, hey, who is this guy talking to? Not just himself, not just Lars, but we've got the Discord chat, which is at adafruit.it/discord. You can go there and look for this live broadcast chat channel. Hey, Paul Cutler, thanks for popping in. And Thin Man, Andy Calloway, hello. What's this about? Andy Calloway says, I noticed the giant Arduino has got one of those roller wheel things pretending to be a power transistor. Do I have the giant Arduino up right now? No, I've put it away. I think it's in one of my little storage bins. A roller wheel pretending to be a power transistor? I think it was a cardboard tube, if I'm not mistaken. I'll have to check. Do you know what I'm talking about? I'll bring that back on. It hasn't been out, the Arduino Grande, if that's what you're talking about. It hasn't been out in a while. So, hey, Sam Blenny, thanks for popping by. Let's get to it. So, first of all, coupon code that I mentioned. So if you want to head over to the Adafruit store and get some stuff, and you would like to save 10% on things that are not software gift certificates or subscriptions, but stuff we'll send to you, then that right there, that's your coupon code. It is Emu Nation. Emu Nation. Ooh, my monitor's so high up. Let's move that. Emu Nation, EMU-Nation. That will get you 10% off in the store today. So you can head over here to this very place, Adafruit.com, and then check out some new products. We've got this View All New Products. We've got different categories. If you look in here on the left in the hamburger menu, if you click on View All New Products, you can check out some stuff that's just come recently into the store. You get 10% off on that stuff. So maybe you need a new heatsink aluminum case fan for your Raspberry Pi 5. That will work. You can throw that in the cart. It's normally $20-ish, and you'll get 10% sliced right off of that. We've got these posable wooden mannequins. These were from which AdaBox? Now I'm forgetting which AdaBox those came in. Was that the last one? Yeah, that was for. Was that number 20? I believe that was 20. That was the camera, the Memento. So if you didn't get one of those and you'd like to get one of those for roughly 80 cents, is that right? No, 90 cents instead of $1. You can do it. You can throw that in your cart. Get a bunch of them. Got these cool square push buttons, the tri-stimulus color sensor, really groovy USB cables, just a couple of the Sparkle Motion stick and enclosure kits left. Any of that, throw those into your into your cart and then use that coupon code right there to save 10%. I noticed in the chat, Andy Calloway says, I grew up in the Emu Nation. Is that New Zealand? Australia? Are those Emu Nations? I don't know much about it. Really, I just like emus. They're neat and terrifying, and since we're talking about emulation, that's the sort of pun. Yeah, Gordy G says, I got one with my camera. I got one of those little posing artist mannequins with the camera. Very cool. Hi, Increda Mike in the YouTube chat says, those are like $5 at an art store, not too shabby. Yeah, I think we must be unloading. We probably, I don't know how many we have, but we've got at least 100, I think. And we're probably just getting them off the shelves. So yeah, pick some of those up. You can paint them, you can modify them, you can drill holes in them, you can add LEDs to them, you can create stop motion animation with them, whatever you like. So I've got a show on Tuesday. I've also got this show on Thursday, but the one on Tuesday looked like that. That's the Product Pick of the Week show. And on that show, I pick a new thing. I give you we at Adafruit, especially the new products team, give you 50% off. And I do a little demo. Here is a recap from this week. Check it out. It is the USB-C CC resistor fixer. Cable to this to Gizmo. Two little resistors on here say to the CC lines, hey, I want 5 volts, please, and it will get the 5 volts, send that along over power and ground. Just looking up at the top here, it says 51% full. I've got a little battery gauge there. It's yellow. I'll go ahead and plug in my cable. It didn't ask for anything. This has not moved to any sort of a charging symbol. If I take my little CC fixer and plug that into the cable, you can see, first of all, if this lights up green, that means that, yes, we are successfully negotiating the 5 volts from the supply. And now when I plug this into my handheld, you can see it has switched to a charging symbol. Yay! The USB Type-C CC resistor fixer. It is the USB-C. Wow, that's just going to loop forever. Sorry about that. Oh, I just saw this guy. Emu. Why is that one smiling? They usually look a little angrier than that. Incredimike in this chat says, I need a handful of those. Yeah, I've just got 2 of them, but they're kind of precious. I try to keep one with that Miu Mini handheld. Right on. So next up, let me get things prepped here so that we can do a CircuitPython Parsec. I just need to adjust this here, camera, and I need to put a weight on the cable. Microcontroller board, very light, and the USB cable is wiggling it around, so let me put a little weight on there. That'll work better. Okay, let's do this. All right, bear with me while I do a quick camera adjust and focus on that little feather board right there. Stay, that's close, okay. And focus. I usually don't keep these, if you haven't noticed, I usually don't keep these in autofocus mode because they tend to dance around a lot with high contrast things, so I like to try to tune that. There we go. All right, wait, let me bring up my code window. And I'm going to close that and open a different one. Very prepared, very, very prepared. Okay, where'd you go? Here we are. Yeah, that's it. Okay. I think that's going to do it. Yes, okay. For the CircuitPython Parsec today, I'd like to show you how you can use a button sequence as a sort of entering combo. So if you need a combination to open a door or something, if you want to make an escape room prop, being able to store up a sequence of button presses and then determine if the user has pressed them in the correct order or not is pretty useful. So here, let me first demo it. If you take a look at, let me set the REPL here to, oh, hold on, I'll close that window. I It's not going to let that one go. All right, let me do the REPL here. Okay, so if you take a look at the little screen here, I've got a Feather ESP32S3 with a reverse TFT on it. And we've got these little buttons on the side here. For simplicity, I'm just going to use this one marked D1 and this one marked D2. And then we can see here it says enter the code. So I'm going to go ahead and press a sequence of buttons, and you can see it says success. Over in the REPL, you can see it noticed I pressed D1 and then I pressed D2, and I'm also storing up the sequence of buttons there in a little list, and then I pressed D2 a second time, and that satisfied the code requirement. If I press those out of order, let's say D2, D1, D2, it says wrong code. So the way this works here, you can see I'm using keypad for button presses and then some display I/O stuff for text. I set up a keypad object here that's watching buttons D1 and D2 that are built onto there. And those are pulled low by default, and they go high when they're pressed. So we can then create this little list here called correct sequence. And you could change this. It could be as long as you need it to be. In this case, I'm just saying the first button and then the second button twice. So index 0, index 1, index 1. That's my list. And then I create this variable to track the input states. I create a little text update here so we can display text by calling this, and we also can reset the sequence just to clear out that little list that I have. In the main loop, we check for events, and that's a keypad feature. If a button gets pressed, first we're going to grab the button index. It's either index 0 or index 1. And then we're going to append that number to the current sequence. So it's initially just that empty sequence or empty list. And then the first time I press something, like this case, that just entered a 0, and you can see it there in the brackets. I'm also using some convenience functions here to string format that so that I can print it out just in the REPL. And then I'm also setting a little asterisk here to show that we have progress. We've added one button to the little list. I'm going to press a second one. You can see now my sequence list has gone to the first button and the second button, or index 0 and index 1. Then we're going to check if we have a length of 3 in that list. If that gets to 3, which it did just then, we're going to do a comparison. So we'll say if the current sequence is the same as that initial list, which was called the correct sequence, then we will update the display with the piece of text that said success, and I also print to the REPL correct sequence entered. If not, we'll do that again. We print out wrong code to the screen, wrong sequence down below, and just for simplicity here, you wouldn't want this in real code, and this is not very secure, I should say. We can look at what we were expecting to get and then what we did get. And then we just do a little couple second pause there after it prints the message, and then we reset the sequence and we're ready to enter again. And so that is how you can use a button sequence as a combination to open something. And that is your CircuitPython Parsec.
CircuitPython Parsec.
Hey, no audio, thank you. Thanks Dave Odessa in the chat. Incredimike says muted. Andy Calloway, Todd Kurt, Charles Burniford, appreciate you. Yeah, I was just yammering away. I was just saying that I turned on my AC and was wondering what I was doing next, but I figured that out. So if any lip readers are out there, you can confirm. Nothing important happened. So what I want to do next is take a look at this Learn Guide recap. Let me head on over here. So if you go to learn.adafruit.com, in case you don't know, and I'm going to see, can I widen this out to become a non-mobile sized screen? Let me shrink that down. Maybe. Let's go to Learn. Yeah, there we go. So if you go to the main Learn page from Adafruit, just click on Learn up at the top. There's a section called New Guides, and you can click on this button here that says View All. And then you just scroll down a little bit. You'll see the Larzio Paint Music icon there with a little Lars and a heart and a meatball and a star and a robot and a drum icon. So click on that. That'll take you to the Learn guide here. And the first purpose here is just to do a little quick recap of the Learn guide. If you want to see this in action, you can check the last couple of episodes, not the last one I did, but prior to that, there's going back a few. You can see it in action. There's also some video of this in action in the Learn guide, and I won't demo that here today, but it's essentially a simplified remake of the music composition section of the Super Nintendo cartridge Mario Paint, which had this cool music composition section that uses synth and sample sounds. And one of the reasons I wanted to show this is because this was actually originally conceived as a Fruit Jam project. So since this sort of is like an old school console or an old school computer, it seemed appropriate to do this sort of project on it. And this has a DVI out for HDMI video. It has a audio out from a DAC. It has inputs for the mouse that I'm using in this case and something else like a keyboard or a gamepad. And it's running the RP2350 processor on there. So the cool thing is you can, even though we haven't come out with this yet, it's still in the works and there's still some revisions to come, you can do a project like this on the Metro RP2350 and you'll have almost all of the same features built in, and we've got convenient add-on breakouts to pick up the ones that aren't built in. So if you take a look at this page called Metro RP2350 DAC Circuit, here you can see I've got the Metro, I've got the HSTX connection there. I didn't draw a ribbon in, but you'll see how to plug that in on this previous page called Preparing the Metro RP2350. So this will show you how you can add some headers for USB, for the USB host, and it will show you there's a nice image of the HSTX connection with that ribbon cable there. If you then go to this, we pick up the DAC circuit that we're missing, and that'll show you how to plug in the pins that you're going to use for both the I2S audio, that's a high quality digital audio for the DAC, as well as I2C, which is used to send commands to the DAC. All of that happens on this. It's the same chip right there. There's the headphone out. It's connected to not SPI. It's connected to I2S. It's connected to I2C, all under the hood. Really, the only difference between that setup with the Metro and this one on the Fruit Jam is the pin numbers. And so I actually wrote the code so that it will check which board it sees and instantiate things like the DAC using the proper pin numbers. But otherwise, these are basically identical. There's nothing different to say about HSTX. It's just a board-defined set of pins, USB host, all of that just kind of works. So this is how to wire that up. And if you want, you can do other projects. It doesn't have to be this one, and get yourself in the headspace of this Fruit Jam that'll be coming. That'll pertain to another project that I'm showing in a little bit. So wanted to show that. And then I've got the code Larzio Paint Music here. It is a, there's a UF2 file and a whole ton of samples, assets for the bitmap sprites, libraries, all that stuff is in the bundle, so you can grab that. And I think I tell you in here which version of minimum version of CircuitPython. And then this talks about, and I've shown this stuff before a little bit in the past, but this will give you a nice overview of what each of the modules are, because this is broken out into a bunch of different Pi files that are the modules for doing different parts of the program. And also pertaining to something I'll be doing later, I wrote this with Claude AI, Claude Desktop, or actually Claude Code, so that it could alter my files on disk in a little sandboxed area. So this is a more sophisticated program than I would normally write as a non-coder, more of a scripter type of person myself. I don't identify as a coder, but along with Claude, which does a really good job. It seems like it's been trained on a lot of Adafruit code, so it does a really good job of writing code the way we typically would. Let's see. Yeah, there you can just continue on. We've got a little demo there you can check out, and shows you what to plug in for your HDMI, for your audio out to some sort of amplifier or headphones. This will work nicely as a headphone amp if you don't want to bother other people. And then also plugging in a mouse over that little USB-A breakout. So on the final Fruit Jam, you'll actually just have the ports right there to plug your mouse or keyboard or controller into. This gives you a little guide on how to pick your different voices or channels, set down notes, loop or not loop, stop, play, and then clear everything if you need. So go check that out in the Learn Guides today or tomorrow, but not Saturday. All right, let's see what else. Next up, Andy Calloway says, if you leave the mic off, we can't hear the air conditioning. Okay, this is a good point. So next up, let's do a little bit of kind of a review of this emulation stuff. So if you look over here, I'm just going to point. I'm not going to move, but I'm going to point a camera over here for a second. Put myself in the corner. So if you look over here, what you can see, I've got a nice little multi-input, multi-format monitor, and it has 2 games showing on it right now. I'm going to go ahead and point out, this in the corner here is an original Nintendo plugged in over composite video, and I have a picture-in-picture capability on this, so you see a little Super Mario running on there. And then I'm going to unplug this current one. I'm just going to go back in time a little bit to this PicoNES, and I'll give you a little backstory on that. But this is the sort of revision 2 PicoNES that gave us a Pico 2, a 2-player, player 1, player 2 inputs, shift register controllers, so I'm using original NES controllers there, SD card, and a little power switch. So if I give this some power, you'll see this boot up to its little menu screen, and then I can pick a game. I'll pick Super Mario Brothers. And once the screen settles down, you'll see here we've got a couple of games of Mario going on here. You can see there are some differences. One, this picture-in-picture input I don't think is capable of being set to a 4:3 ratio. I think that may be fixed at this 16:9, so it's stretched. This one's proper 4:3 ratio. You also notice this one looks a lot brighter. One reason is this is using some simulated scan lines in the code, and I don't think we can turn those off without recompiling. Color's a little different, but otherwise, it's as far as gameplay goes, it's a great emulation. So you can see, compare my gameplay over here, speed, input really fast, and that compares well to over here in the corner where I've got Mario running on a NES, the original. I'm just going to squash this guy and jump here. so that's the original. I'm not playing audio, although this PicoNES does send audio over the HDMI to that. So let's talk about what these are. So that, I said, is the sort of second revision of PicoNES. Here was the first. I'm going to show you my down shooter here. So that is sort of the original PCB I did for this. You can see we've got a Pico 1 on here, SD card breakout, HDMI breakout. You can play it in a couple of modes. One, if you use a power injection on-the-go cable, you can use a USB controller, like a PlayStation controller, DualSense, or even DualSense or DualShock, plugged into the USB. I think these are less laggy. I think there's a little bit of delay. I could be wrong. I haven't tested that, but I feel like these are a little snappier to use original style NES or SNES controllers with these, with the shift register input. And that's some code that Phil Burgess contributed to this. So this is the original. Let me go show you some info on the project. So this is the Learn Guide that we put together, and those credits right there are actually pretty important. So Jay Kumagata did the original InfoNES emulator. I forget what that was meant to run on, actually. The port to Pico was done by Shiuchi Takano, and then Frank Hodemaker, who's on there as Friends, did the menu system and SD card support, which means you don't have to bake ROMs into the thing or copy them over USB. You can just put your ROMs on an SD card and you can pick them with that little menu system. And then Phil Burgess did the NES and SNES and Wii controller support. So you can use a thing like the Nintendo Wii Classic controller that has a I2C connector, that little funny little Wii connector. You can plug that into this over I2C and use that as well. So there's a bunch of people who've contributed to that and more. And you can check out the GitHub there. You can just go to our Learn Guide here and find out more. So that was the original there, and then I followed it up when Frank got this running on Pico 2 and added 2-player support over the shift register real controllers. So that's kind of the preferred one right now. That one works well there. You can see it in 2-player mode. It's me and my wife playing some Bubble Bobble. And there's a demo there of it running on the original. So you can go check that out there. And then what's going on now, what's new is, and I think I'll see if I can show it from a top view camera there for a second. So what's going on new is this here, which is that same Metro RP2350 with a DVI output using the HSTX. This DAC you can ignore for now. It's not hooked up. Hopefully that's I'll get the pin numbering figured out from that, because Frank was using a different DAC at first. So I'm going to give power to this using, as I mentioned, this little splitter. So this red cable is going to the Metro's USB-C, so we're getting data and power there. I'm injecting the power using a micro cable, just because that's the kind of splitter I have right here, although I have some USB-C ones on order. And then this is a PlayStation DualShock. Is that what these are called? It's from a PlayStation 4. It's a PlayStation 4 controller, whatever their name is. It won't work wirelessly on this, but this is connected over USB, so it's being hosted by that. So that's the setup. Could you see any of that? There you go. That's the controller, and that's the little USB injector thingy. And if I go to my main cam view here, you'll see this is now a new cut, and this is not out yet. Maybe you can find the artifact or whatever they call it over on Frank's GitHub, but he sent me this one just for testing. But this is looking really promising. So we have video, we have the controller. We've got no menu yet, but I can pick games holding a little button combo on the controller there. So you can see I've got Contra and Donkey Kong and Super Mario Brothers. I'm having a weird issue with color, and I don't think Frank was having that same issue, so I'm not sure what's going on right now. But you can see that is a very weird color for Mario. And I can press start and play, and you will see a very red-blue color swapped version of Mario there. Let's see what buttons do that. There we go. But it's playing great, which is exciting. We can go back out to the menu at any time, just cancel the game, play something else. So those are just a few games that got baked onto there. I believe Frank is working on the menu system and SD card support as well. So with any luck, we'll have a nice port of this on RP2350, which should then get us to that running on a Fruit Jam. And there could be more. Frank's got a Sega Genesis / Sega Master System emulation running on RP2350 Pico right now, so hopefully we'll be able to get that over to this kind of setup. But that is just a little bit of a history of kind of where we've been and where we're going with some pretty cool NES emulation. Yeah, Incredimike noticed I do have a SNES port on there. They're compatible, so as long as you figure out the pinouts, you can actually use an SNES controller, just not all the shoulder buttons and things, but the same buttons that do exist on a NES controller, you can use those on there. That seemed like just to keep the size down, I kind of ditched that when I went to this version here. Let me pull that controller out. This version here, which is actually player 1, player 2. So I didn't think we needed the SNES ports on there, and it was a little confusing. And to emphasize it, I did a little controller artwork on the back there. And all of these files you can find if you want to get PCBs or make your own. There's also in those guides, much like my RP2350 one over there, there's instructions for putting these up on breadboards or perma-proto boards if you don't need or feel the need to get a PCB for it. But they make nice gifts. There is a pretty cool little case available. It's mentioned in the Learn guide for that one. So hopefully we'll do some nice, I think the Rees brothers are going to do some nice case design for Fruit Jam. I'm not going to try to wrangle all of this onto a Metro. I think I'll just wait to put it on here because that'll be the nice preferred format. And that could make a nice little compact gaming system and maybe a nice little gift. So that's where we're at with that. Let's see, what else next up? Oh, I didn't mention before, and I'd like to mention if you feel like saving money, using that coupon code, go buy stuff. The thing I forgot to mention is that if you buy enough stuff, you get free stuff, which is pretty cool. If you get an order together with $99 or more, you will get a free PCB coaster. If you spend $149 or more, you'll get the PCB coaster and a KB2040 keyboard, very cool board. And then if you spend $199 or more, you'll get the coaster and the KB2040 as well as free ground shipping with UPS in the continental US only. So those are some freebies that you can get, and they stack. So if you want to get a bunch of stuff, I know shipping is expensive for buying just one little thing. So if you want to get a bunch of stuff together, save some money, you'll hit those breakpoints. You'll be able to get some free things for it. Okay, so next up, let's turn this AC back on for a minute. I want to do a little gear report thing. So this is not an Adafruit thing, but this is something I found really useful. It's inexpensive. You may already have one. You may know about these. I kind of vaguely knew about them, but never had one, and now I'm glad I do. This was actually a gift to me from C. Grover, who had sent me some Eurorack stuff that had this attached. It is a little task light, kind of like old console lights you'd find on mixing boards and stuff like that. That is a very nice, holds its position kind of gooseneck. It's USB. It is a little single LED there. And these are great just to plug into the side of a laptop if it's got a traditional USB-A cable. Most battery banks still do, so you can set that there, and it's light enough to just turn pretty much any little USB battery pack into a lamp. And it uses very little current, so you can last a long, long time on a battery pack. I'll show you. I decided to use one of my little USB current measure gizmos here. So if we plug this in, you can see the light is on. I'll switch over to the down shooter, and you'll see we're drawing about 30 milliamps. So that'll last a long, long time on a little battery like this. So I have this just plugged into a USB hub on my computer in my office. There's a hub that I have that sort of sits right under my monitor, and with this there, it's really helpful for when I grab a board and need to go plug a wire into it and kind of can't see too well because it's too dark. So super useful. It doesn't have an on-off switch. It doesn't have color changing. It doesn't have focusing the beam or anything like that. But they're super, super cheap. They're $7.99 at IKEA. If you have an IKEA, you could probably order one and have it sent. I don't know what their shipping is like, but that's the lamp. There may be other models, other colors, but I haven't had a lamp like this since I had one on like a Nintendo Game Boy Color that had a weird little, they call it the worm light, and it was an incandescent bulb, and it was barely bright enough to help much with that terrible screen, but this is a much better version of that. You could use it as a book light. You know, some of those book lights have batteries built in and LiPo charging and all that now, but for even on airplanes, if you've got a battery with you, which you probably do, you don't need that. You don't need to meter it, but that kind of thing right there, really nice. You can make, you know, modern lamp designs with your battery packs. So that is my little unsolicited, not paid for by IKEA product recommendation. Thanks to C. Grover for sending me that. I am going to get more of them. I've got an IKEA I can go to, get some meatballs, some ice cream, some rye crackers, and some of these neat little lamps. Do you have any favorite lamps? I'm interested in more task lights. So if you've got nice task lights, tell me more about them. I have, what was the traditional console light? Let me look this up for you. I've got one that I need to get a replacement bulb for that I really like. There's one brand who made these forever and ever and still does for like mixing boards. What is it called? Mixing board, or for light boards in a theater. Mixing board light. Lit light. These things. Lit light. They probably are LED now, but I have kind of the old school xenon or whatever they were that have the little transformer and plug right into AC, or some of them have these little XLRs and can plug right into your like phantom power on your board. Anyway, these are expensive. They're great. They're heavy duty. They'll last forever. But I'm kind of digging this $8 jobby from IKEA as a viable alternate to that. Gordy G says $5.99 Canadian. There you go. Nice bargain. Okay. So let's see. Other updates. Let me switch over to. Let's go over to the Workbench. Let me move some stuff out of the way and talk to you from there. So let's head over here and kill that again. I just wanted to show you some of the parts I'm collecting for the dance shoes, the Drag Artist dance shoes with synced sparkle motion. So I'm going to turn off the NES. I'm also going to pull a cartridge out. I don't like to leave the cartridge in because it kind of flexes the pins on there, which is something that likes to break. And I'm going to move that. Okay, so you should be able to, I don't have anywhere to move these things to, so I'll just get them out of the way. I should be able to see all that. So this is the demo of the Sparkle Motion that I've showed, I think it was 2 weeks ago. I'm actually going to steal that little battery pack back so that I can light one of them up for you. So here is, let's do this one. Here's the one that I encased for demo purposes to see how the microphone would work through our plastic. So there you can see that's lit up, and I won't mess with the exposure on the camera, but you can see there it's sound reactive. Doot, 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 doot. And it's also FFT, so pitch, frequency. Green when I'm whistling high, and otherwise it's down the purple and blue. So these are going to be going into these platform shoes, and turns out my favorite little battery here, they do make it in white. So I got a couple of these little AtomTech power banks in white, and I got some very short flexi, I haven't even opened these yet, let's see. Very short flexi, it's a pack of 3 of these USB-C cables. So let's just test one there. This is the other Sparkle Motion. Which one do I have? That one there. And these little power banks have USB-C out. Let's see, you're gonna work. Yay, yeah, so I don't know what that one's set to right now. Oh, I think it's waiting for sync from the first one. So if we power on, I'll just plug that into the other one. It'll be a little more exciting. So this is one I had been using, but it's came with an 8-bit DOE. I can't buy that one separately. Came with an 8-bit DOE controller. There we go. Yeah. So we're back in business with these nice little short, and this might have been, I don't know, $8 for the 3 cables. They're nice woven, flexi. Looks like they'll sit nicely inside of the shoe, and we can. The more white things that I have in there, the more light will get bouncing around on there. I didn't want to add a bunch of dark colored stuff inside the shoe. So those are my 2 little additions. Of course, some of this stuff comes and goes. I got these on Amazon, and they will, I'll put links in the guide when I put that together. Just waiting on shoes right now. So once I get those, I'll be able to put those together proper. But those are the little additional parts that just came in. Yeah, if you didn't know, as I work on projects for Adafruit Learn Guides, there's a kind of a flow to the ordering stuff in advance, getting it, building projects, and thinking out 2 projects in advance on starting to put the circuit and the code together. So we are in it on that one. I'm kind of early stages on this one, which will ultimately be a Fruit Jam one. And then I have a follow-up project after these that's going to do a similar, I'm going to do a similar lighting thing, but with something else, something other than shoes that I'll just tease that right now, but won't tell you about. So those are the projects. That's what's going on with those, collecting parts. And let's see, coming back over here, we've got in the chat, Incredimike in YouTube chat says, IKEA has another clamping gooseneck light that I like, but I've already broken the clamp. Oh, okay. Sam Blenny says, my favorite task light, small rechargeable video light with hot shoe mount and an 11-inch magic arm and a Visa mount, cheese plate, aluminum base. All repurposed gear for making DSLR camera rigs. Oh, very cool. Parts are from Small Rig, Newer, and CavMate. Ah, that's great. Yeah, you know what? I have a little... You might have seen these before. I used them with some of the Memento projects, and I actually have one charging right now. These are some Small Rig lights. that I do like a lot. These are good for lighting, like lighting stuff for video or photography. It's got multiple brightness levels and turn it off. Rechargeable over USB-C, and it has like a little clamp system for putting filters in and little barn doors and other stuff, diffusers. There's little magnets on here you can snap on some stuff. And these are not too expensive, and I think you can get them in packs of 3. So those are kind of a nice, very specific light, real small. You can then decide how you're mounting it to things. So yeah, I like those a lot for photo lighting. Todd says, those little flat power banks are great. Well, you recommended them to me, so I'm glad you like them. I think I saw in your video, in Todd Kurt's videos, there's a lot of these little cool little battery packs. And I think, what are these things, 5,000 milliamp hour? 3,000, yeah, 3,000 milliamp hour. So they are probably something similar to this on the inside. I think this is a 25. This is a 2,500 milliamp hour. So they've got something that's just a little bigger than that inside of there, but those work great. Really like them. Ruiz Brothers showed one nice power bank. Yeah, if you catch up on yesterday's 3D Hangouts, the Ruiz Brothers had a really cool power bank. It reminded me of a miniature version of some of the car starter batteries, if you've ever got one of those sort of emergency jump start batteries that are USB out, and sometimes in their case the DC barrel jack out, and you can get 5 volts and 12 volts out of them. So they're going to use that in their camera slider. All right, so then the last thing I wanted to do, let me just check my notes. Yeah, so I thought this might be interesting to, as I had mentioned earlier, in creating the Larzio paint program, I used Claude, which is a LLM for coding. I'm going to still try to be grumpy and not call it AI, because come on, it's not AI. But I used Claude for coding, and I wanted to show what it looks like doing a sort of typical simple example of using Claude Desktop here in alongside CircuitPython to create some code and alter it, kind of what that looks like for the curious, if you haven't done this already. What I found is that I like this. I had used ChatGPT, and that was okay, but just the UI, as well as some of the integrations that I've used with Claude Code, which allows you, as I said earlier, to have little servers, little plug-in add-ons that can alter files on your computer, and you can sort of tell it where. You can kind of sandbox it into an area and say, files in here is where we can write new files. If you need little helper Python scripts, we can rewrite, we can save. And then there are, of course, GitHub integrations. I haven't gone as far as that, but I think Tim has. So maybe he's shown some of that on Deep Dive with Foamy Guide. But this is a little Metro RP2040. I've got a Neopixel Grid on here. I'm going to cover that with a bit of diffusion plastic just so that it's a little easier to look at. Let me put that like so. Can I get that? Oh, I've got a little screw on there that's going to keep that propped up. So that's pretty good. And then hopefully you can see on my screen here, I've got my coding window. I'm going to make that a little bigger for you. Maybe like that. And, oh, Todd asks, are you using an Adafruit corporate Claude account or just a personal free account? You know what's funny? I am on the Adafruit one, but I think when I just logged in here, it thinks I'm not, because it says free plan upgrade. So we'll see how far we get. But yeah, Adafruit has a corporate account, which I'm part of, and I think that's what enables the Claude Code, which I'm not doing on this computer here. But this is similar. What I'm going to show here is probably similar to what you'd get with the free account or a personal account. So how this works, I've got, yeah, evening. So we've got Claude. Am I on even desktop? No, just in the browser. They have a desktop app that makes some little UI improvements, but this is just in the browser. I'm logged in, and what I'm going to do is say I've got a Metro RP 2040 with a 8x8 Neopixel RGBW Grid plugged in on pin A0. Create example code that demonstrates changing colors. All right, so that is not hugely detailed, but I kind of like to give it a little, I haven't pointed at any existing code. I haven't said here's where the sample lives on the internet. I'm just going to see how well can it do here just with a simple prompt. And then you can see it's created what they call an artifact, but it's this window off on the side where my code is printing out. And then on the left, it will describe what it's done usually. Okay, so I can tell that it has gone and found some examples of typical Neopixel demos, because it's, even though I just said show color changing, it went and found a breathing demo. It's made using a color wheel code. So let's see what it said. It said this code demonstrates several different color changing patterns for your grid. Key features: RGBW support, so it'll maybe get it right. We'll see. I'm guessing it'll have might not have the orders right. Multiple patterns, solid color, rainbow cycle, waves, checkerboard, spiral fills, breathing effects. Optimize performance, use auto write false. That's good. Pattern explanations, I'm going to ignore that for now. Okay, so I will just copy and paste that into my code window. I'm already noticing it's doing some weird stuff. The way it's formatted things here. Def main, like this doesn't look like typical CircuitPython code. So I'll try it. Let's see if we get any. Okay, it's very bright, for one. And I don't know if it's gotten the color order right or not. So what I'm going to do is I'm actually going to say simplify example to just flip from red to green to blue to white, and set brightness to 0.2. We can go back to previous ones. So once I say, oh, okay, I see what it's done maybe with the color order or something like that, you can see up here it says V2. So this is the second example it's made. So I'm going to come over here. I'm going to copy this. I'll paste it and save it. Red, green, blue. Okay, got the color order right, and white. That's excellent. So GRBW color order is what it got. And that's probably because it's the most common out there. So it's probably what it found. Yeah, watch your eyes. So this is still too bright. Let's go to 0.005. Or 0.05. There we go. That's better. I can also change the exposure. Let me adjust the exposure on my camera here. There we go. So what I'll do in these cases is I've started to make changes, like I'll adjust the way something works. For example, I don't even know why it's doing this if name equals name main. I may be curious enough to say why, or explain. I like explain this. And I'll just copy paste. I don't really worry about formatting. If I put a colon and paste a bunch of code, it usually knows what I'm asking for. So it says this is a common Python idiom that checks if the script is being run directly as opposed to being imported as a module. All right, so I don't want that. So what I'll do, rather than argue with it about it, I will sometimes go and head back to my code, get rid of the weird stuff there, just outdent that. I don't need to define the function main. Oops. So at least in this stage, I like to go and change some stuff by hand until it's a little closer to the way I'd want it. Okay, this looks a little more like I'd want. So then I'll copy this, and I'll come back over to Claude, and I'll say, using my code, create an example that fades between colors for 1 second duration, colon, paste. And the reason I like doing it this way, like I said, is it can kind of go off into some odd ways of doing things that don't make sense to me, which makes it harder to go and edit later. So I kind of like to reel it back and do something that makes a little more sense to me as I'm working. So here you can see, I'll read what it said. It says, this code creates smooth fades between each color over 1 second. Here's how it works. Added a fade between colors function that smoothly transitions between two colors, uses linear interpolation to calculate intermediate color values. 50 steps over 1 second gives smooth 20 millisecond updates. We'll see. Cycles through red, green, blue, white, red, and it repeats. How the fade works, take a start color and end color, divide the 1 second duration into 50 small steps. For each step, calculate the intermediate color by blending. So does it use a linear interpolation? Is it importing that? No. They might have just, it's just created its own linear interpolation function. I think there is a lerp that's built into CircuitPython, so we may ask it to try that just to see if it's better, different, simpler. Factor goes from 0 to 1. Float, for example, fading from red to green, and then it shows some of the numbers it's going to use. All right, well, let's try that out. So I'll hit copy up here, over here, paste. The big difference with this and Claude Code setup with some of the little servers and having it write is that you could, I haven't had it write directly to the microcontroller. I've had it write to my file system, and then I increment stuff and copy it over. But I think you could have it, give it permission to use your CircuitPy drive, and then it could just write these files as you're going if you wanted to iterate really quickly. So it looks like it's doing a nice job with the interpolation, cool. And then this is just, that works, so it could be done. For some reason, I'm like, wait, isn't there this lerp function? Is there, a lerp function you could use? Question mark. CircuitPython doesn't have a built-in lerp function, but we can create our own to make the code cleaner. Okay, so that's maybe it, and maybe someone in the chat can tell me. I think maybe it exists in a library like math, or like Simple IO or something. Is there a lerp function in another CircuitPython library such as math? Question mark. It's me being lazy. At this point, I could go out to the web and find that answer. It's doing that. It's searching the web. It got 10 results. It says, based on my search of the CircuitPython documentation, the math module provides basic mathematical functions. It does not include lerp. Okay. So may just be building that, or again, if anyone in the chat knows, let me know. But this is kind of a typical back and forth for me with this. I then might go in and say, I want to add a button, or I want to add a sensor. I want to use something that's built into the board, or I want to start using things that are plugged in over I2C. And that's where I can start to build up a thing. Like if, for example, we have Let's see. I'm trying to find one that's simple enough that it won't. Let's see, do we have a user button on this? I don't think we do. And you can ask some questions like that, sometimes not. I'll ask it. I'll say, can the boot button on Metro RP2350 be used as a user button? If so, adjust code to pause and resume fade with that button. It's pretty good at it. I didn't tell it, oh yeah, well let's go ahead and keep diving into this lerp thing. It kind of knows that I gave up on that. Boot cell button is primarily designed to enter bootloader mode, can be used as a user input button in CircuitPython. However, the specific pin name for accessing it isn't clearly documented in the search results. All right, let's see what it does. Other interesting thing, because you know, as you probably know, these types of large language models guess the next smartest letter to type or word or idea, and then occasionally you'll see it undo as it goes further, and it kind of realizes it's kind of backed itself into a corner. So it's not just marching through linearly creating the code. Sometimes it'll delete whole sections and say, I've come up with a better way to do that, which is kind of funny to watch. Let's see. So here's what they say they're going to do. Updated code includes pause resume function using the boot button. Boot tries common pin names, board.boot, board.boot cell with fallback. Pull up resistor, boot buttons are typically active low, debouncing, pause state, responsive, checking. At this point, I may dive back over into my REPL and try to check what that button is called if it's user accessible. So I can go Control C, import board, dir board, and see if anything has the name boot. No, it's just going to fail. I don't think that that button does not exist on this apparently. Other thing I'll do at this point is go to learn Metro RP2350 pinouts. Often it's in this pin diagram, so I can see boot cell. Okay, so it's GPIO24. So maybe that can work as GP. Is it GP24 in CircuitPython? I think it'll be GP24. So what I'll do is try their code, paste it, but instead of trying this boot cell thing, I'll try GP24. Save that, restart the board. Boot button pin not found. I don't think it's GPIO24, is it? I don't think so. Nope. Nope. Interesting. So at this point, I might ask it, "Hey, wait, I want some more checking error codes to tell me what it tried, what it didn't work with, that it noticed that I did press something or didn't notice that I pressed something." But yeah, that may be a dead end with that. I could do some more exploration, or I might plug in a button and use that. So let me know if you have any thoughts or questions on that, but I thought it might be interesting to see, just even on some simple examples, how I'm finding that useful for code that typically, for something like this, I would have gone to an example code, learn guide, something like that, the docs, start cobbling things together, but things will be all kind of a little slightly different from each other. Variable names won't match. So I like Claude for this kind of stuff where it's just going to generally work, generally consistently pull together the right code for something like that. All right. So I think that's going to do it. Again, let me know in the chats or comments if you have ideas about that, thoughts, questions, things you'd like to see me do or try along with that. But that is it. So again, before I go, I'll remind you, Emu Nation, Emu-Nation, EMU-Nation is your coupon code for today. That'll save you 10% off in the Adafruit store. So go get some neat stuff. It's how we stay in business. We want to stay in business. It's how we get to do shows like this and put out our learn guides, drivers, hardware, open source, and more. That is it. So I will see you next Tuesday for product pick of the week. And in the interim, we should have a deep dive with Foamy Guy tomorrow, some videos from Lady Ada over the weekend, and we'll be back to, as I said, product pick on Tuesday, 3D Hangouts on Wednesday, show and tell on Wednesday, Ask an Engineer, and more. Thank you so much for stopping by the workshop. For Adafruit Industries, I'm John Park, and I will see you soon. Bye-bye.